morning everyone. Good morning. How are you all? Today's topic, you can read here, reflection from plane surface. Do you remember what we did yesterday? Yesterday we have discussed object and image primarily, like what is object, what is real object, what is virtual object, how object is formed, diverging, converging. These all concepts we have done. Incident ray decides object, reflected refracted rays decide images. That we have done, right? Now today we are going to discuss this phenomena called reflection, and in the last of yesterday's class we discussed the law of reflection also. Angle I equal to angle R and all lie in the same plane. So today we are going to get this reflection from plane surface idea. Focus it, is a very interesting topic. Focus so that you will be able to answer questions when I will ask you to. So first of all, in this surface, reflection from plane surface we can take as a plane mirror. So we will say take a smoother surface, we will discuss smooth reflection, right? A smoother surface, how to make, see, from one surface, when light falls on a surface, when a light falls on a surface, it reflects as well as it refracts. Both are taking place simultaneously. If you want to make reflection dominant, more of the energy you want in the reflected, less energy you want in refraction, then you have to make this surface smoother, more polished surface, more smoother surface. What they will do, they will reflect it back. So that is called a reflecting device. Reflecting device, where device is actually giving more of the energy into reflection and less energy into refraction. But as a matter of fact, these two, reflection and refraction, reflection and refraction, they will take place simultaneously. So when I say reflection, that does not mean refraction is absent, but that we'll discuss tomorrow. Tomorrow is for refraction. So in this question, just a basic discussion. Suppose one light ray is coming like this on this. Yesterday's discussion, just a primary revision. Can you tell me what image will form at this point? Ray is getting incident. What image will form, everyone? Try to answer, real image or virtual image. What we are making here? Real image will form or virtual image will form. So from here light will reflect back, from here light will reflect back, and they will incident at this point. And since they are actually getting incident, ray is going away from the mirror, so that is called reflected ray, and they will form image, and that image they are making by the actual coincidence, so that is called the real image. Moreover, if image is real, then here you will have virtual object. So that is the case we discussed yesterday, virtual object and real image. Then again, if I will take question like this, this is object and that is a smoother surface that will give you more light as a reflected light, and when light ray is going here incident, and from this point they will reflect back. According to angle of law of reflection, these two angle, incidence reflection will have the same value. Here also with normal, incidence reflection will have same value. Reflected ray is here, These two reflected ray, they will appear to come from some point, their image will form. Since it is appear to come, they are not actually coming from that point. Appear to come means virtual. So that is what image? Virtual image, and here will be real object. So that the concept we have discussed yesterday. If you remember, I asked you regarding ghost also. The ghost you cannot see, and also that we have discussed yesterday. Okay, we have discussed already yesterday. So today we are going to discuss the plane surface exclusively, and for that, this is the point number 1. Every point, example, discussion, one by one we will do. See this, everyone. What happens in plane mirror reflection? Note this point. Distance of image from mirror is equal to the distance of object from mirror. It means when we have a plane surface reflection, that is a plane surface reflection, this is the plane surface, and here is object. Object is at a distance, let's say x. So image will also be at the same distance x. Does not matter your image is real or your image is virtual, whatever pair between object image is going on, but you have to take in mind the distance of object and distance of images, they will be same. That is the point written. Most of all in this point, this is your plane mirror, that is the plane mirror, and this plane mirror is at rest. that at rest is called static. When we say static, this means we are talking about rest. This plane mirror is at rest, right? And it is at rest, so object image distances are same from the mirror. When the mirror will move, when it will start moving, this is our mirror and this is moving. Let's say velocity of mirror I am writing as v. With what velocity it is moving? It is moving with velocity v. Now obviously, when try to understand this, mirror is moving, so object distance will increase from the mirror. Objects in mirror is going, mirror will be at this position, so object distance that was earlier x, now that distance from mirror will keep on increasing. Object distance is increasing, then image distance will also increase, because what will happen here? The object distance and image distance, distance of image from mirror is equal to the distance of object. So if mirror is moving and object distance increases, object distance from mirror is why it is increasing? Because mirror is going away. So image was here, image will also move that point away from the mirror, so that from mirror image distance will also increase. So always object and image distances will have the same magnitude. If your mirror is static, same. If your mirror is moving, object distance is increasing, image distance will always increase. If you are, all of you, try to place yourself in front of a plane mirror in your house and go towards the mirror. When you're going towards the mirror, your distance from the mirror is decreasing. So your image distance will also decrease. So in any situation, in any case, the object image distance will be same, even if your plane mirror is at rest or your plane mirror is moving, or whatever will the case, the object image distance will not change. But having said that, one thing you have to keep in mind, when I'm talking about distance of image, that distance is, it must be on a line perpendicular to mirror. On a line perpendicular, that is called normal. Normal we talk about, no, incident ray, reflected ray, normal. So on a line perpendicular to mirror, we are talking about this line only. So that distance will remain same, but on which line? On a line perpendicular to mirror. You can say this line is perpendicular to mirror, this line is also perpendicular to mirror, this line is perpendicular, this line. So object and image distances are measured on perpendicular line, on normal, and they will have always the same magnitude. That is the characteristic number 1. So that is the characteristic number 1 for plane mirror reflection. Any doubt in this? Now you can ask, I will answer that. We will go on second characteristic. Okay, try to understand this. I am summarizing this. No one is asking any doubt, only movie plus is saying. So I am just summarizing this. Example is there. That is a plane mirror. That plane mirror is moving. That is moving, let's say, with 3 meters per second, right? Plane mirror is moving. How it is moving is not actually a concern. How it is moving, we don't have to. It can move on a bike. It can move anywhere. It is moving. That is given. But I am standing here, and when I am standing here, I will see. Just imagine in your mind, some plane mirror is there. You are moving. Then also relatively mirror is moving. So you are moving or mirror is moving. Suppose I am static. There is a mirror. I am looking at my image in the mirror. Now that mirror anyhow is going away from me. So my image will also go away from me. That image will not come towards me. So that point I am saying, if that was the original distance, and that distance I am taking as, let's say, 10 meter. 10 meter. Can you tell me in 3 seconds I am asking, or 2 seconds? In 2 seconds, Abdul, how much distance mirror would have been covered? If I will calculate that from the basic kinematics, distance is velocity into time. So that mirror velocity earlier we have taken as 3 meters per second, and after some time the mirror has now covered velocity into time, that is 6 meters. So mirror has covered 6 meters, and I was originally at a distance of 10 meters. So now from the shifted position, my distance is 16 meters, 10 plus 6. Earlier my image was here, initial image I am saying here, and that was at a distance from initial position of mirror 10 meters. So object, image and object image distances are same. Now since mirror has shifted 6 meters, so you can see the object distance from the mirror is 10 plus 6, Abdul, that is 16. So your final image will also be here, and that from this position will be 16 meters. So that I'm saying from this characteristic, the object distance and image distance, they will have the same value. Doesn't matter what, only one thing take in mind, or always keep in mind, that I have written there. Okay, whenever these are taking place on the line perpendicular to mirror, this you have to keep in mind. Your distance measured, I am measuring that distance 10 meter or 16 meter or whatever, that should be measured on normal line. So whatever distance from mirror you are having due to velocity of mirror, due to velocity of you, the image distance will also have the same value. Okay, see, number is written, you will have many characteristics. In first characteristic, I want to say ki image and object distance will have the same value along the normal, even if mirror is moving or mirror is at rest. This much only I said. In this any doubt, let me know. Otherwise, I will come to the next characteristic. So I am going to second point. Now read the second characteristic. See, we will discuss one by one all characteristic. In one characteristic, if you try to explain, take explanation of all of them, we will get confused. So one by one. Now see this. Nature of image produced by plane mirror is opposite to that of object. That was issued doubt yesterday. Virtual, it always plane mirror always forms virtual image, and many students think like this, but we have to conceptualize it. Nature of image produced by plane mirror, whose nature I am talking about? We are talking about image nature, and that image nature is always opposite to that of object. It does not matter real or virtual, but whatever be the object, image will be opposite to that. That is the second characteristic. Okay, nature of image produced by plane mirror is opposite to that of the object. That already we have discussed example. If I have, or you can see in the previous example, see here, when image is real, your object is virtual. And when your object is real, then your image is virtual. So image and object will always have opposite nature. We will not take in mind that plane mirror always forms virtual image. That will be wrong. That depends how the image, what is the nature of image, that will be depending on nature of object. And whatever nature of object is given, we will just reverse it. That will be nature of image. Everyone is asking why angle I equal to angle R. That I will discuss in today's class. So you no need to type. That is already in my mind. Okay. Have you guys done your diligence? Have you found why angle I equal to angle R? Because yesterday only 2-3 students were replying this answer. So I will take this today in last, right? Let me complete this. Jaswant, now you say, if I am saying image distance equal to object distance, then what will be magnification? Image produced by, this is the third characteristic. Image produced by a plane mirror is erect and laterally inverted. Here someone was asking this and telling this also. This is very, very important. Laterally inverted. It is not simple longitudinally, laterally, left, right, right. Someone said, no, we are raising right hand, so left hand. Now understand this concept. Second is simply, here if I am writing object as real object, image will form virtual. Their nature has to be opposite. If you want me to draw the ray diagram once again for you, I am drawing it. This is the object, real object. So real object will go on the plane mirror. That will go on the plane mirror and it will reflect from here, right? When it is reflecting, these two are reflected ray. And if you want image, you have to coincide reflected ray. So reflected ray are not getting coincided. So I will coincide them apparently here. They appears to coincide and here virtual image is formed. Suppose that is a plane mirror, and in this plane mirror, if I am taking virtual object, I don't know where is object, virtual object. So incident ray is coming like this, incident ray is coming like this. And whenever it is converging ray, yesterday I told you converging incident ray means virtual object. So it will reflect from here and they will form what kind of image? Actually they are intersecting, they are not apparent extension. So this is called virtual image. Why I am saying this to be image? Because they are coincidence, point of coincidence of reflected ray. So they will form image. And these incident ray will appear to coincide. They are not actually coinciding, appear to coincide. So that is called virtual object. So that is the second point. Santosh or Jaswant was asking this. What just it is saying कि object and image nature will be opposite. You cannot be very much sure about the image कि virtual only will form or real only will form. Any image can form depending upon the object, but nature will be opposite to that of object. Okay, that is okay to all of you. Second point. Now come to the third point. read this here. Understand the basic concept. Heading, you have to read what is meaning of laterally inverted. Focus on this. This is one of the important discussion of all the characteristic today. That is a plane mirror. So this is beta plane mirror is there. What mirror is there? Plane mirror is there. In plane mirror, in front of it, I am putting any object. Ishwar, you told me you are 2D or 3D or 1D. Ishwar, you are 1D, 2D or 3D. Or any one of you who is standing in front of mirror and realizing how beautiful or handsome are you. In that process, what kind of body are you? You are 2D, 3D or 1D? We all are 3D, my dear students. How can you be 2D? Are all of you planar body? We have length, we have breadth, we have height. We are 3D. So 3D body means what dimension we are having? X-axis. What dimension we are having? Y. What dimension we are having? Z. So we are having 3 dimensions. We are having 3 dimensions, X, Y and Z, right? Length, breadth and height. Now, light ray will fall on the mirror. Light ray will strike on the mirror according to which axis? Which axis is incident on the mirror, that we have to check. So, image gets inversion only along the axis, perpendicular to the mirror. So you have to check the diagram which axis is perpendicular to the mirror. To this plane mirror, which axis is perpendicular? So I get the answer as X. X is striking the mirror. It is along the normal. So when I will go in image, the image x-axis image will be inverted. There is no change on y-axis and there is no change on z-axis. Got this? Let me explain this with an example, but first understand the fact what I'm trying to say. Summarize it. I'm saying, someone, Krishna, you are asking no, why it is laterally inverted. That point I'm explaining. Image production I am focusing on. Image. This is image. But any object which is in front of that plane mirror, it will have 3 axes. Some might have said 2D is a hypothetical body. Every body is 3D. Some thickness is small is everywhere. But we are only interested in that axis which is normal to the mirror. That will be reflected. Why it will be reflected? Because obviously ray will go here and image will send it back. So incident ray is responsible for object and reflected ray is responsible for image. And you can see very clear that their directions are completely opposite. So incident and reflected. So reflected is responsible for image. So image, this axis. If light ray is going along y-axis, you all think if this ray is going, will it ever strike the mirror? It is not striking the mirror. It is not incidenting the mirror. When there is no incidence, there is no reflection. And when there is no reflection, there is no image formation. Similarly, if light ray is coming towards you like this light ray is not going to incident the mirror because mirror is standing here. Again, this light is not incident on the mirror. There is no reflection. There is no image. So only incidence is for X. Only incidence is for X. So only image formation is for X. And that will be inverted. Right? That is point number 1 I told you. Image gets inverted only along the axis perpendicular to the mirror. If I take some example in this, everyone, you have to see the screen to understand it. So you have to be little focused here. Suppose I am going this screen, this board, whatever is near me, that is a plane mirror. Imagine, and I am going from left to right. This way I am moving. Imagine my image inside it. My image will also move left to right, or my image will move right to left. That answer I want from all of you. If I am moving, no supplementary statement, beta. Just tell me answer. I am going from left to right. So my image will go left to right or coming right to left. All of you have to answer it. I am going from left to right. My image will also go from left to right. Why? Because I am moving in this direction and beta, that direction is not perpendicular to mirror. So for inverted lateral, Krishna, for lateral inversion, your light ray should be perpendicular to mirror. If your light ray is parallel to mirror, your image is not getting inverted. Now all of you please imagine at night, dark house, 1:30 AM, you are moving in front of your mirror and your image is moving in opposite direction in the mirror. That is the scene of a horror movie. If you are moving like this, your image should move along with you. If your image is coming from opposite direction, that is a very scary moment. That should not be. Only opposite direction will be this way. If I'm moving like this, my image will come like this because this direction is perpendicular to the mirror. Now again read this. Image gets inverted, inversion only along the axis perpendicular to the mirror. Don't blindly always write ki left, right, right, left. Someone said ki I am saying rising right hand and this is left hand. That is only when you are facing towards the mirror. When you're standing like this, your right will be right, your left will be left. There will not be any inversion. You can try this at home. Okay. Suppose I'm writing one name here. Now understand the lateral inversion. Take one example. Whose name you want me to write here? Any suggestion? Whose name I should write here? Whose name? Name. I'm going to write a name. Tell me first name I will take, that I will write. So first I got Ishwar. Okay. That is written there. Now see its image formation and same concept. Image gets inverted only on perpendicular line. If you're not focusing it, you're not getting it. And when I'm explaining something, try to understand the concept rather than raising question just after my concept explanation. I will give you time to raise doubts. But please understand this. This is letter E. This ray is striking mirror perpendicular. This is striking mirror perpendicular. This is striking mirror perpendicular. So their images will be inverted. But that portion, the straight line portion of E, that is going like this. And this dotted line, you can see, this dotted line is not striking the mirror. So dotted line will remain as it is, but lines which are striking the mirror, they will be inverted. They will be inverted. That is written, only inversion on perpendicular line. So E will be look like this. Similarly, in S word, if I am going, this is striking, this is striking. So that will be reversed like this. W, this line, W first line, that is not striking the mirror, that will be as it is. This line will be as it is. So W will be W. Symmetric diagram is this. A is also symmetric. In R, that line will remain, straight line will remain as it is. But these curved portions, they are striking mirror perpendicular. So it will be inverted. So inversion only takes place for those rays which are getting perpendicular to mirror. That is the only thing I want you to get. If you are moving parallel to mirror, there will not be any inversion. That is the concept I want all of you to understand. Next time you will not blindly say that lateral inversion everywhere. You have to understand inversion only takes place for that axis, for that length which is perpendicular to the plane mirror. Okay, have you got this? Now any other name? So I'm writing Deepak now. Okay, every point I have taken, don't worry. You are asking many points, every point is there. Now suppose this, just an example to understand. You know this concept, Deepak I am writing. Now in this Deepak, D has a vertical line. That vertical line is not perpendicular to mirror. That will remain as it is. But this curved is going perpendicular to mirror. So that will be inverted. E already I have written in the Ishwar name. E and second E. P. Vertical line for P will not be inverted. Vertical line is not perpendicular to mirror. But this curved portion will be inverted. Here is A and then here is K. K also see. In K, this line will remain as it is, but this is going on the mirror, striking on the mirror, so that will be inverted. So only those lines will be inverted which are striking the mirror perpendicularly. Okay, erect means same. Saraswati, erect means the vertical height, the direction. Erect, I am drawing a diagram for you. Here Saraswati only for you exclusively. This is the plane mirror and I am saying erect. Erect means this is the pointer, it is going up. So the image will also be like this. So arrow is up here, arrow will be up here. That is erect. Means A will never be inverted. If I am writing A, that will never look like this. That is called inverted, Saraswati. And erect means it will be always in the same portion, right? If I am writing suppose S and I am writing here, it will never be inverted like this. Inverted R I am writing here. So R will not be look like this. This is called inverted. It is always erect. Erect means same vertical height will be there and same direction will be there. Above horizontal R is up, so it will up only. It will not be like this. That is called erect. Okay. Position will be same. Already tell movie plus. Position means object distance will be equal to image distance. That already I told you. Second point also I told you ki nature will be opposite. Third point I told you ki image will show lateral inversion, but lateral inversion will only be along that axis which is perpendicular to mirror. If you are parallel to mirror, inversion will not take place. Erect means if any word, any letter, any object is like this up, it will be inverted laterally, but it will not be going down. Inversion down, vertical inversion is not possible. That means it is erect. Okay. Now read this. Someone was asking about magnification. First of all, what is magnification for any optical device, whether it is a lens or mirror, reflecting or refracting? What is the magnification? So when we are writing magnification, in most of the cases, magnification when you write means you are writing image characteristic or image property upon object property or object characteristic. What I mean by this property or by this characteristic means, suppose I can write image distance upon object distance, that I am writing. So what property I have chosen? I have chosen distance. So I will compare distance of image to object. Or I am writing height, that also someone has asked earlier. What property I have chosen here? I have chosen height of image. So when I am writing height of image, then I will compare that height with the height of object. That is called magnification. So all idea about magnification is you are comparing image with object. One property of image you have taken and the same property of image you are comparing with the object. That is all idea about magnification. But earlier I have told you, if someone has joined late, please have a look. The first point, distance of image from mirror is equal to the distance of object from the mirror. So when both distances are same, so whatever object distance, suppose I am taking image distance as x and object distance also has to be same, x. So what magnification is coming? 1. That's why I have written there, magnification produced by plane mirror is unity, means plane mirror will not zoom any object. You cannot have a larger image as compared to object. Whatever is the size of object, height, width, everything, that will be same in the image. Yes, exactly, everything will be same. Height, length, width, everything will be same. Okay, every dimension. I have written height. If I can write length of image, what characteristic, what property I have chosen? Length. And then I am comparing this with length of object, that also will have the same value. So any property of image compared with the property of object will have the same value. That is the magnification unity. Next, field of view. Now understand this everyone, field of view. What is field of view? In this field of view, first you understand one point. If your house got windows and you are looking the outside world from that window, so window dimensions, window area is very small, still the area of image or area of outside world that you are able to view from that small window is quite large, almost infinite times more than the area of window. So what you see does not matter from what opening you are looking at. It means if a plane mirror is very large or if a plane mirror is very small, very large, very small, that does not, size of plane mirror does not matter. A small plane mirror can also give you the full image. Obviously depends where you are putting it. If you are putting plane mirror in backside of you are not looking at it, obviously will not find any image. That location, that everything we will discuss, but point is field of view. Field of view is that field through which image can be seen. If one definition I will take, magnification of plane mirror beta Saraswati will never be -1. It is always 1. -1 will not be there. Okay. Now see this field of view. How to write? Simply if definition I am writing, Babu, field of view, it will be the field, the range of reflected ray. Reflected ray. Don't forget we are talking about plane surface reflection only. Range of reflected ray from which image can be seen. Image can be seen. Okay. It means if I am drawing this plane mirror and this diagram so many times we have written, there is a real object. Every object in our surrounding is real object only because they send diverging rays. This is going here and that is going there. On the extreme of plane mirror, two light rays are intersecting and then they are reflecting back. Please read this, range of reflected ray. So this reflected ray is here, that reflected ray is here, and this complete is called range of reflected ray. Range of reflected ray beta. And when you will see the image, from where you are looking at the image, this reflected ray will appear to come from a point, that reflected ray will appear to come from a point, and here image is formed. But where image is formed, that is not important. Point is, one observer is standing here. Will he be able to see this image? Obviously yes, because reflected rays are going here in the eyes of that observer. If one observer is standing here, will he able to see the image? Answer is yes, obviously. And many rays will be going in this range, right? So this entire range is called field of view. So if that is the dimension of your window, you are not actually looking this much area only, you can see the larger area. So field of view, as the name suggests, the viewing field, the viewing range, that is called field of view. So this is the basic definition I have just taken, what is field of view. Now suppose I am taking one example. This is a person, right? That is head of a person, that is eyes of the person, and these are the feet of that person. Head, eyes, feet, and in front of him some mirror has been placed, that is a mirror. Got it? If person wants to see his full image, I am talking about full image, if I want to see my full image, on my eyes, feet image and head image both must be formed, right? Okay, so see here, at this point ray is going here, striking and coming back, ray is going here, striking, coming back to eyes. From feet also it is going and coming back to eyes. So that angle, incident law of reflection, this angle, let's say alpha, so that angle has to be alpha. And this angle, if I am taking here beta, so that angle has to be beta, because angle of incidence is angle of reflection. And since angles are equal, so these two distances must be equal, that is x and that is x. Here also these two distances must be equal, y and y, because angle are same, corresponding distance will be same. Don't actually look into the real measurement. Alpha correspond to y, then alpha correspond to y, beta correspond to x, then beta correspond to x. So total height of that person becomes 2x plus 2y. Whereas if you will see the height of mirror only, that is the plane mirror, if you will see the height of plane mirror, that will be here to here, that is only x plus y. X plus y. It means person height is twice of mirror. So we can say, to say full image you are looking at, to say full image, height of mirror should be half the height of the person, whoever is looking at. If a person wants to look, person height is 6 feet, he wants to look, so mirror minimum height should be 3 feet. But this has got a condition. Can any one of you tell me the condition behind it? A person of his total height h can see the half height, mirror should be of half height, then only full height can be visible. But what is the condition in it? Anyone who can write the condition? I am saying try to understand fact if you have not understood this. A person of height h, can see his full image, if minimum height of a mirror, minimum height of a plane mirror, we are discussing plane mirror today, a plane mirror is h by 2. But this comes with condition apply. That condition you have to tell me, and that is your homework question for today. So we are left with two homeworks, y angle I equal to angle r, and second, why this, what is the condition in this. These two will be our first discussion in tomorrow's class. First we will discuss this, then we will go on refraction concept. Okay, not moving back. Bye everyone. So that is for today. Tomorrow two homework I have given, that we will discuss. We'll see you. Bye. Enjoy your good marks now.
Good morning everybody. So today we are going to practice questions based on all the three concepts that we have studied till now. Okay, I will mix the questions and give you. Are you all ready to do those questions? Just type a ready, then we will start. Are you all ready to do questions of all three types? Just the way we did in the first session, we did questions, time-based question on mole concept. Today we'll do time-based questions on stoichiometry. Yes, very good. Before we start, kindly like the video first. I saw yesterday only 126 likes were there. But if there are 200 students, I must see 200 likes. Minimum. Okay? Just takes half a second to like. Okay? Just take half a second to like. If you like the video, it will give us confidence that yes, the video is reaching to you and you are really liking the content as well. Okay? Let us start with the questions now. I will be giving the question and I will start the time. Each question. So I have taken 10 questions for you today. Okay? Total marks 40 marks. Okay? Total marks are 40. Number of questions are 10. Each correct you will give +4. Each incorrect you will give -1. Okay, let us start. For each question, I will give you 2 minutes. Nobody will talk about anything else. We know Luffy. Okay. All right. Let us start. Question number 1. Here both the concepts are there. There is a concept of limiting reagent as well as the concept of percentage yield. Little difficult question. I'll just write the names of those who are giving different answers. Almost many people are saying 50%. Many people are saying 50%. Most of you. Now I'll start with the answering. You can all see here, beta. 2x react with 3y plus 4z gives 5w. I will think reaction is occurring normally. First thing I'll find the limiting reagent. Why limiting reagent? Because moles of x are also given, moles of y are also given, moles of z are also given. So I'll take given moles by stoichiometry. 1 mole of x, stoichiometry is 2. 3 moles of y, stoichiometry is 3. 4 moles of z, stoichiometry is 4. So x becomes the limiting reagent. 1 by 2. This becomes the limiting reagent. X says I will decide. Now, if 2 moles of X are used, then 5 moles of W are produced. So, 2 mole X produce 5 mole W. Okay. If 2 mole, yes, 50% is correct answer. Very good, everybody. 2 mole X will produce 5 moles of W. We have taken 1 mole of X. So 1 mole of X will decide. 1 mole X says 1 mole X will produce 5 by 2 mole W, which is 2.5 moles W. This is not the answer, bache. This is theoretical yield. I told you yesterday for the product, actual yield will be theoretical into percentage. I told you yesterday. Theoretical W into percentage. So product is obtained less than expected. We were expecting 2.5 W, but only half we are getting, 50%. Very good. 50%. Well done. Those who have given 50%, Navdeep was the first person to say. Navdeep, congrats. You got the answer first. 50% is correct. Okay. 50% is correct. Is this clear to everybody? Should we move to the next one? Yes or no? 1.25 by 2.50 into 100. 50%. Okay. Let's move to the next one. Question of a similar type. Just the oppositely given. Just the opposite given. Now yield is given. You have to find the product. Previously I gave you product. You found the yield. Most of you are saying the answer is 0.75. Okay. Reaction says 2A reacts with 3B plus 5C to give 3D. I'll write the reaction. 2A, 3B, 5C gives 3D. Now moles are given, so I'll take given moles by stoichiometry to find the limiting reagent. 2 moles of A are given, divided by 2, which is the stoichiometry. 4 moles of B are given, divided by 3, the stoichiometry. 6 moles of C are given, divided by 5, the stoichiometry. Okay, so we get 2 by 2, 1, 4 by 3, more than 1, 6 by 5, more than 1. This is the limiting reagent. A says I will decide. So according to A, we'll make the product first. 2A give 3B. 2 mole A give 3 mole D. If everything is 100% fine. Everything is 100% fine. Then we have taken 2 moles only. So answer is 3 mole D should form theoretically. Then tell me, should I increase the D or should I decrease the D? Should I increase, should I decrease? Quickly, we should decrease. Yes, because D is a product. I will decrease the product by multiplying with percentage, as I told yesterday. So answer will be actual D, actual amount of D will be, percentage is given 25%, 25% of 3.75 mole. Clap for yourself, those who gave the answer. Ishwar was the first person. Ishwar, congrats. All of you are doing correct. Good. Next one. Start. Many people are saying the answer is D, myth. Most people say D. Now let me try and let us see what will be the answer. Which is the limiting reagent you got? Tell me. Okay. The stoichiometry says 1 carbon, 1 hydrogen, 1 oxygen. First thing, we must balance the reaction, bache. Those who have not balanced, you will never get the answer in your life. Because mole concept requires balancing. First, balance. Balance. Did you balance or not? 12 carbon. 12 carbon. 22 hydrogen. 11 H2. 11 oxygens. 11 oxygens. Already beta 2 are available. So I have to take 11 by 2. 11 by 2. Yes. So first we'll balance. 12, 11, 11 by 2 gives 1 product. Stoichiometry is 12, 11, 11 by 2 and 1. Now we have to do given moles by stoichiometry. First we'll see how many moles are given. So I'm writing the moles this side. All of you can see. Moles of carbon, moles of hydrogen, moles of oxygen. Moles of carbon are given 84 gram carbon. Means 84 by 12 gram, which is going to be 7 moles. Moles of hydrogen are given 12 gram. 12 gram by 2 gram, 6 mole hydrogen. Moles of oxygen are given 56 liter, means 56 liter by 22.4 liter, which comes out to be 2.5 times 2.5 mole. 2.5 mole. 7, 6, 2.5. So I am doing given moles by stoichiometry, everybody. 7 by 12. 6 by 11. 2.5 by 11 by 2. 11 by 2, 2 comes up. Okay. So these numbers look like this. 7 by 12, 6 by 11, 5 by 11. Which is the smallest number? Which is the smallest number? 7 by 12, it is almost 0.57. 0.58 around. 6 by 11 is 0.5 something, and this is 0.45. So this is the small number. This is the limiting reagent. So oxygen is the limiting reagent. Oxygen will decide. Oxygen will decide. Now oxygen says that 5.5 mole oxygen gives 1 mole sucrose. So 5.5 mole oxygen gives 1 mole sucrose. Molar mass of sucrose is 342 gram, you should remember. or you can add and check. 5.5 mole give this much. Moles given are 2.5. So 1 mole oxygen is going to provide us with 342 by 5.5, and 2.5 mole oxygen is going to give us 342 by 5.5 into 2.5. Now cut it on the table of 5. 5 5s are 5 11s are. On the table of 11, it will go 33 and then 12, which is 31, around 31. 31 5s are 155 grams. 155 gram, which is going to be option number 2. It was a good question, but most of you answered it maybe by looking at Google. Next one. All of you try this yourself. Getting wrong answer is not at all a problem. We are learning now. Viber also, no problem. Do the next one, everybody. Being honest is the best policy. Good sign up. Let us see, all of you. Mass of Mg3N2 produce 48 gram magnesium reacted with 34 gram ammonia. Reaction is given, magnesium plus ammonia. Did you all balance or not? Did you all balance or not balanced? Balancing was done or not done? If you don't balance, you don't get the answer, bache. 3 magnesium, 2 nitrogen, 2 nitrogen, 6 hydrogen, 3 times 2, 6 hydrogen. This is the balanced reaction. 3, 2, 1, 3. 3, 2, 1, 3. I will start by writing given moles by stoichiometry. Given moles by stoichiometry. Now, 48 gram of magnesium. So, moles of magnesium given are 48 gram by 24 gram, which is 2 moles. Moles of ammonia given are 34 gram by 17 gram, which is 2 moles. Both are given 2 moles. 2 by stoichiometry 3, 2 by stoichiometry 2. Limiting reagent is ammonia. I will decide. Ammonia will decide. Okay. 2 mole ammonia give 1 mole Mg3N2. 2 mole ammonia give 1 mole Mg3N2. I'll write the mass of Mg3N2. 1 mole means 3 magnesium, 24 times 3, plus 2 nitrogen, 14 times 2 gram Mg3N2. 2 mole only are given, so this is the answer directly. Full 2 mole ammonia is getting consumed. So this is the answer only. Okay. Mass of Mg3N2 produced if 48 gram magnesium metal reaction. Okay. So 2 by 3, 2 by 2. So we get, this is the final answer, which is going to be 24 plus 24 3 times, which is 272 plus 28, which is 100 grams. Okay, 100 grams, which is actually 300 by 3. Did we balance it properly? One time we'll check again. 3 magnesium, 2 nitrogen. Okay, 100 is the answer. Nowhere it is mentioned. Did anybody get 100? Mg is the limiting reagent. 2 by 3. I'm so sorry. This is the small number, no? Magnesium says, I will decide. Okay. So correct. 2 mole magnesium. So when we look at the stoichiometry, that's correct. Absolutely correct. When we look at the stoichiometry, 3 mole magnesium produce 1 mole of Mg3N2, which is 100 gram Mg3N2. 3 mole produce this much. We have taken 2 mole of magnesium. All right. So 3 mole produce that much. 1 mole magnesium produces 100 by 3 gram Mg3N2. That's correct. Absolutely correct. And 2 mole is going to produce 200 by 3. 200 by 3 is the answer. Which option was 200 by 3? First option. Okay. A is the correct answer. By mistake, I have removed the question. A was the correct answer, 200 by 3. Absolutely fine. Those who said A is correct. Okay, good. Next question. All of you try this. Be a little careful while solving this question, everybody. One question I'm asking everybody. one question. Will decomposition of 100 gram CaCO3 always produce 44 gram CO2? Tell me. This is the reaction. Will 100 gram of CaCO3 always produce 44 gram CO2 or no? Answer is no. No. It will not produce. Why? Reaction may be only 50% efficient. It's like a question. If you study for 10 hours, will you always get 200 marks? No. I might be not studying efficiently. Tomorrow is the exam of chemistry, but I studied physics for 10 hours and went. I'll get 0 marks. Yes or no? So studying for 10 hours does not always get you full marks. You have to study properly, efficiently. If tomorrow there is an exam of chemistry and I study biology and go, I will not get marks, no. Yes, so depends. So now you see the options. 2a plus 3b give 1c. 2a plus 3b give 1c. They are saying statement 1, 4 by 3 moles of C are always produced when 3 mole of A react with 4 mole of B. Given moles by stoichiometry. 3 moles of A react with 4 moles of B. Stoichiometry is 3 by 2, 4 by 3. Which is small number? It is 1.5, it is 1.33, it is the limiting reagent. Okay, no doubt, limiting reagent. Now we'll see how much C will produce. Okay, so 3 mole B gives 1 mole C. 3 mole B gives 1 mole C only if reaction is 100% efficient. So 4 mole B will give 1 by 3 into 4, 4 by 3 C. But this is theoretical. This is theoretical. In our real case scenario, 4 by 3 might not come because we might not be able to have proper temperature for the reaction. We might not have pure A and B. So answer is always produce. No. Only if reaction is 100% efficient. Then only this statement is true. So always is not correct. Okay, always is not correct. B is the limiting reagent for the given data. Answer is correct. So 1 is incorrect, 2 is correct. Option is C. I know most of you would have got the wrong answer here. Answer is C. Sixth one. All of you try. Do we know the reaction CaCO3 gives 1 CO2? Answer is yes. So if I start with 100 gram, I should get 1 mole CO2. Means 22.4 liter CO2. But instead 22.4 liter, I am only getting 1/4 of it, 5 liter. I should get 20 liter, but I am getting only 5 liter. Means it is 25% efficient reaction. How many percent efficient reaction? On heating gives 5.6 liter CO2. Find the percentage of calcium in the limestone. Okay, that's a different question only. That's a different question only. Find the percentage of calcium in the limestone. It is not, okay, it's a little bit of a long question here. All of you see here. Little bit of a long question. All of you see here. Little bit of a long question. Okay. So first thing I came to know that CaCO3, all of you see here, very nice question, gives CaO plus CO2. Okay. First I am finding how much percent CaCO3 is actually available here. How many grams of CaCO3 is actually available here? I am trying to find out. Okay. Now, if I start with 100 gram CaCO3, it should have given us 22.4 liter CO2 theoretically. Theoretically. So this is theoretical product. So we know that actual product is theoretical product into percentage by 100. All of you see here, it's a nice question. All of you kindly look at here. Or look at this. So we get actual amount of CO2, which is coming how much? 5.6 liter. Theoretically 22.4 liter into percentage by 100. So we get percentage purity of CaCO3 coming out to be, from here you can solve it, 25%. Okay, this is not the answer. This is the percentage purity of CaCO3. Yes, 25% pure. Now let's look at the question again. Question is, find the percentage of calcium in this sample. Percentage of calcium means nothing but they are asking percentage of calcium, which is weight of calcium by weight of limestone taken into 100. Weight of calcium by weight of limestone into 100. Okay. Now, how much calcium is there? Limestone to is 100 gram. I know limestone to is 100 gram. But how much calcium is there? Let us find out. Very good question. All of you see here. I just came to know if this is the 100 gram mixture. Out of 100 gram, only 25% means 25 gram is CaCO3. 25 gram is CaCO3. Now I need to use the mole concept and check how much calcium is there in 25 gram CaCO3. How much calcium is there in 25 gram CaCO3. So we'll write the mole data of this. Okay, what was the mole concept? Mole Brahmastra, everybody, mole Brahmastra. 1 mole CaCO3 means 100 gram mass. And it contains 1 mole calcium. 1 mole calcium means it contains 40 gram calcium. It contains 40 gram calcium. So 100 mein there is 40 calcium in 25 gram. So in 100 gram CaCO3, there is 40 gram calcium. In 25 gram CaCO3, there will be 10 gram calcium. I hope all of you are getting this. In this whole 100 gram of the solution, there is 25 gram of CaCO3. In this 25 gram of CaCO3, there is only 10 gram of calcium. Rest is carbonate. Yes, is it clear? So we get percentage of calcium as 10 gram calcium in total 100 gram of limestone into 100, which is 10%. So this became kind of a chocolate question where 2 things you had to do. Clear? Rest 4 questions are your homework. 1, 2, 3, 4. 4 questions are your homework. Take care. I hope it is clear to everyone. Okay. Bye-bye.
Hi students. Hello, good morning. Our today's botany topic, pollination. It is a very, very essential phenomena for sexual reproduction in flowering plants. In all plants in the plant kingdom, only some of the plants are specially able to perform pollination. For example, there is no pollination in algae, no pollination in bryophytes, no pollination even in pteridophytes also. In gymnosperms, a little bit pollination is there. Angiosperms, very highly evolved pollination is found in angiosperms. What is pollination? It is the transfer of pollen from anther to stigma. Transfer of pollen from anther to stigma. Observe here. Anther is the pollen producing site. Stigma is the pollen accepting site. In this pollination, one should be donor, another should be acceptor. Who is the donor in this concept or pollination mechanism? Anther is the pollen donor. Stigma is the pollen acceptor. Based on donor and acceptor relation, pollinations are classified into different categories. Both pollen grain donor and pollen acceptor found within a single flower. Then the pollination within a flower is known as self-pollination or autogamy. Another name of the autogamy is the self-pollination. Pollination within a flower is autogamy and self-pollination. Pollen grain donor, anther, and pollen grain acceptor, stigma, both are present within a same flower. Then that is the self-pollination. Pollination between the 2 flowers, cross-pollination. Before going to the types of pollinations, we should learn about the 2 types of flowers. Flowers broadly 2 types, open kind, unopened kind. Majority of the flowers are open type. Very few types of flowers are unopened. Technical name of the open flowers are chasmogamous. You might have seen several types of flowers in nature such as open kind or chasmogamous. In examination point of view, definition for the chasmogamous flower is the flowers which open are called chasmogamous. Chasmo, open. To receive pollen from other flower, to send their pollen to another flower, flower should be open at maturity. Observe these images here. Petals completely opened out for the facilitation of entry or exit of pollen. Here also petals completely open to facilitate exit of pollen or entry of foreign pollen. These kind of flowers are very common in flowering plants. Technical name of such kind of open flowers, chasmogamous. Chasmo. In Greek language, chasmo means open. Usually these are cross-pollinated. It is a valuable point. If the flower is open, then only cross-pollination is possible. Without opening of the flower, cross-pollination not at all possible. Next, second category. Clistogamous. Clistogamous flowers. Clisto, unopened or closed. The technical name of clisto is unopened or closed. Some plants, such as viola, plant name, common name is the common pansy. And second example, oxalis. Third one is the comulina. In these plants, flowers are unopened, such are called clistogamous. These flowers do not open at all. Always in closed condition. Appears like a buds. Always closed condition, appears like a bud. The reproductive organs of that flower not exposed to outside. Such kind of flowers are unable to receive pollen from other flowers. These flowers, the anther, stigma, lie close to each other. These kind of flowers are unable to receive pollen from another flowers, and at the same time, the pollen of this flower unable to move from this flower, lack of open condition. When anthers are dehisced, dehiscence means breakage or cleavage within the floral buds, the pollen grains come in contact with the stigma of the same flower. Then self-pollination occurs. Without pollinators, any kind of pollen transferring agents, self-pollination is possible in clistogamous. Cross-pollination is failed to occur. One of the major disadvantages of clistogamous flowers, cross-pollination not at all possible. Only the possible kind of pollination is self-pollination. Self-pollination. Clistogamous flowers produce assured seed set even in the absence of pollinators. Even in the absence of the pollinators, pollinator means pollen grain transferring agents like wind is one of the pollen transferring agent, or water, or animals like insects act as a pollen transferring agents. In absence of these agents, pollination is possible or seed formation is assured. That is one of the single advantage of clistogamous flowers. Most of the features are disadvantages, but one advantage is there. Assured means guarantee seed formation is there even in absence of wind, water, insects like pollen transferring agents. It is about the clistogamous. Tell me once again, what is the difference between chasmogamous and clistogamous flowers? Yes, open flowers are chasmogamous, unopened flowers are clistogamous. Both self-pollination, cross-pollination are possible in chasmogamous. Only self-pollination is possible in clistogamous. It is the major disadvantage. Next, depending on the source of pollen, pollination is of three types. Three types of pollination. One is the autogamy. Another name of the autogamy is the self-pollination. Another name of autogamy is the self-pollination. Now, if the pollen grains are transferred from anther to stigma of the same flower within a single flower is the autogamy. Other name is the self-pollination. Both the pollen producing pot and pollen receiving pot stigmas are found within a single flower. Autogamy. To possible autogamy, flower should be bisexual. Is another technical point here. To possible autogamy, flower should be bisexual. If both male organs stamens, female organs carpels present in a single flower, such kind of flowers are called bisexual. that bisexuality is essential for autogamy or self-pollination. Next, geitonogamy. Pollination between the two flowers of the same plant. Geitonogamy. If the pollination takes place between two flowers, but plant is the same. Within the single plant, two types of flowers are there. One is the pollen donor, another one is the pollen acceptor. That is the geitonogamy. G-I-T-O-N-O, geitonogamy. Example, maize plant. Maize. In the plant maize, flowers are unisexual. Both male female flowers are present on same plant body. Then pollen transferred from male flower to female flower. But two types of flowers essential to possible geitonogamy. Next, xenogamy. The pollination takes place between the two plants. Plants physically, two different plants are there. Pollination between the two flowers present in two different plants of the same species. That is the xenogamy. I will explain once again these concepts through the blackboard. That is the plant body, flowering plant, pedicel, stalk of the flower, thalamus. The swollen tip of the flower is thalamus. It possesses male organs, stamens, female organs, carpels. Stigma is the pollen accepting portion or receiving part. To the presence of both androecium and gynoecium, these flowers said to be bisexual. Observe the plant A, in which both male female organs are there. That's why this flower is called bisexual. Whereas in plant B, only androecium is there, no gynoecium. That's why this flower is unisexual. That flower is unisexual. Within the same plant, one more kind of unisexual flower is also there. Pedicel of the flower, thalamus, and female organs like carpels are there. Identify the difference between flowers of the plant A to the flowers in the plant B. In the plant A, flowers bisexual. In plant B, flowers unisexual. Both unisexual, male, female, present on same plant body. Okay. Plant A possesses bisexual flowers, whereas in the plant B, unisexual flowers are there. Unisexual flowers. Next, whereas in plant C, all the flowers are same kind. All the flowers are same kind. Carpels, ovaries, style and stigma. What about the plant C1 and C2? Plant C1 consisting of male flowers only. The number of flowers, whatever it may be, but all the flowers are male flowers. Hence, the name of the C1 is the male plant. C2 is the female plant because all the flowers in this plant, entire plant, are female flowers. That's why it is termed as a female plant. On all flowers, carpels are there, whereas in the C1, all the flowers are possess androecium. That's why these flowers are male. B and C, one common feature is there. In the plant B, C1, C2 flowers unisexual. But the major variation from B to C, both male female flowers present on the same plant body. Hence, the sexuality of this plant is the monoecious. Sexuality of this plant is monoecious. Whereas in the plants C, is single plant possesses either completely male flowers or completely female flowers. If only male flowers are there, that is the dioecious male plant, it is the dioecious female plant. So, the sexuality of the plant C is the dioecious plant. Okay. B is an example for monoecious. C1, C2 are an example for dioecious plants. Both male flowers, female flowers present on same plant, that is the meaning for monoecious. Only male or only female flowers are there, that is about the dioecious. Papaya plant is example, male, female separate. And palm trees also very good example for dioecious plants. Dioecious condition is the very rare in plants, but most common in, this is the most common in animals and human beings. Most of the animals are dioecious, but most of the plants are monoecious or possess bisexual flowers. Now the types of pollinations. Pollination broadly divided into two categories. One is the cross pollination. Another one is the self pollination. The technical name of the self pollination is the autogamy. Likewise, the technical name of cross pollination is the allogamy. ALLO. Allogamy is another name of cross pollination. Is the pollen transfer from anther to stigma of the same flower. It is the meaning for self pollination or autogamy. Is the pollen transfer from anther to stigma present in two different flowers of the same plant is the geitonogamy. Cross pollination further divided into two categories. Geitonogamy is a kind of cross pollination. This is the geitonogamy. Is the pollen transferred from anther to stigma of a flower present on two different plants. If the pollination takes place between the two different plants, it is the xenogamy. Listen once again. If the pollination takes place between the two plants of the same species, xenogamy. If the pollination takes place between two flowers of the same plant, geitonogamy. Hence, both the geitonogamy and xenogamy are types of cross pollinations or allogamy. If the pollination takes place within a flower, self-pollination. Another name of the self-pollination is autogamy. There is no need of two types of flowers for autogamy. Single flower is sufficient for self-pollination. But single plant with two different flowers is sufficient for geitonogamy. To possible xenogamy, two plants, male and female plants, should be required. Listen once again. Pollination within a single flower, auto. Pollination between the two flowers of the same plant, geitonogamy or geitonogamy. Pollination between the two plants of the same species, xenogamy. Both the geitonogamy and xenogamy are the types of allogamy cross pollination. Within these two types, xenogamy is the true cross pollination, or the real cross pollination. The true cross pollination is the xenogamy. Geitonogamy physically appears like a cross, but genetically self-pollination. Geitonogamy physically self, but technically or genetically it is the self, but physically cross-pollination. In all aspects, the true cross-pollination is xenogamy. When the pollen grains are transferred from anther to stigma of the flower of another plant of the same species. So finally you can say two plants are required to possible xenogamy. It is genetically true and ecologically also tree pollination. But vectors are essential or agents are essential to possible cross pollination. Give the answer for this question. Pollination in closed flowers is called closed, means clisto. Clisto means closed. The type of pollination in clistogamous flowers, type of pollination, autogamy. Only self-pollination is possible. Here. Somebody are asking about syngamy. Syngamy is fusion of male and female gametes is the syngamy. Syngamy. Syn means fusion. Fusion of both male gamete with the female gamete is known as syngamy. That is a type of fertilization. Fertilization is different from pollination. Answer for next question. Pollination between two flowers present on the same plant. Pollination between the two flowers of the same plant, single plant. Answer. Plant is the one, but two flowers are there in the same plant. One is a male flower and another female flower. That is the gytenogamy. Is it genetically self but physically cross pollination? Gytenogamy only. First option. Next one. What is the best method for the self pollination? What kind of modification of a flower essential for self pollination? Cleistogamy ensures 100% self pollination. Cross pollination not at all possible. In cleistogamous flowers are unopened flowers. Next, agents for cross pollination. Different types of agents are required for cross, not for self pollination. These agents are broadly divided into two categories. Abiotic, non-living agents. Biotic, living agents. Water and wind are example for abiotic cross-pollination agents. Insects, birds, bats, primates, arboreal some rodents, reptiles, including snakes, all are example for animals. These animals also called as biotic pollen transferring agents. Okay, agents for cross pollination broadly divided into two categories: abiotic, biotic. In these two types of common kind of agents are most common type of pollen transferring agent is biotic agent. What is the agent here? Bird. If the pollination carried by the bird or animals, such are called zoophily. Zoophily. Abiotic agents, non-living agents. If the wind is agent, that is called anemophily. Pollination by wind, anemophily. Pollination by wind is the wind pollination. Another name of it is the anemophily. What are the characteristic features of wind pollinated flowers? It's important area to ask so many questions here. What are the characteristic features of anemophilous or wind pollinated flowers? Wind pollinated flowers. Character number 1. Pollen grains should be lightweight or non-sticky or dry. Other name of the non-sticky is a dry. Then can fly easily in air. Lightweight pollen grain, non-sticky or dry pollen grain. Second point, stigma should be feathery. It is the ovary of the carpel, style. Stigma redivided into many branches. Appears like a feather. Hence it is called feathery stigma. This kind of stigma facilitate to catch airborne pollen. And sometimes the stigma is the sticky also, to easy catching of the pollen which are flight or float in air. Pollen should be dry, but stigma should be sticky. And only one ovule is present inside of the ovary. Single ovulated ovary is also one of the feature of anemophilous plants or wind pollinated flowers. Wind pollination. Wind helpful for dispersal of pollen from anther to stigma of another flowers. Once recollects the characteristic features of wind pollinated or anemophilous flowers. Pollen grain number should be high, light in weight, non-sticky or dry. Stigma should be larger or feather-like and sticky to catch airborne pollen. Next, single ovulate ovaries. This kind of pollination commonly occurs in grasses. Example for wind pollination are anemophilous flowers, grass members. Next, hydrophily. Hydro, water. Phily, liking flowers, water liking flowers. Because water is the agent for transferring of pollen. Pollination by the water is known as hydrophily. Such flowers are hydrophilous. But the rare type among these three types, Anemophilus, Hydrophilus, and Zoophilus. Very rare type of pollination is the hydrophily. Most common type of pollination is zoophily. Most common zoophily, rare kind hydrophily. It is quite rare in flowering plants and limited to about only 30 genera among the 1 lakh flowering plants. Among more than 1 lakh flowering plants are there. In this, within very few species, like 30 genera only, especially these are monocots. The type of pollen transferring agent is water. So hydrophily is the very rarest kind of pollination agent. If the pollination takes place in surface of water, that is called epihydrophily. Epihydrophily. If the water surface is the main agent, pollen released from male flowers float on surface of water. When female flower reaches to surface of water, then that will collect the pollen which float on water surface. So water surface is the medium for the pollination. That kind of hydrophily is epihydrophily. Example, Vallisneria is kind of aquatic plants or hydrophytic plants. Next, cast feature of entomophilous flowers. Entomophilous means insect pollinated. Insect pollinated. Pollinated by animal generally called as zoophily. One of the best example for animal that act as a pollen transferring agent, insect. The pollination by the insect is known as the entomophily. Pollination by insect is entomophily. Animals like rats also act as a pollen transferring agents. Lizards. Flowers of this entomophilus are larger, colorful, fragrant, that can emit good smell, and nectar rich to attract animals or birds or insects. One is the large and colorful, showy, big flowers, emit good smell, fragrant. Nectar content is more to attract insects. Suppose the flowers are smaller at the time, many smaller flowers are aggregate to form a large size structure that is called inflorescence. Observe in the plant sunflower, many smallest florets are aggregate to form a large flower. In marigold also, chrysanthemum, chamanti also, inflorescence is there. That inflorescence is formed by the aggregation of or assembling of many small flowers to improve the beautiness of the inflorescence or flowers to attract pollen transferring agents like insects. Once give the definition for entomophily. The pollination by the insects. Entomophily. Most dominant type of insects in pollination, honeybees. Honeybees are common type and dominant type of pollen transferring agents. Majority of the crop plants, rice crop, wheat crop, maize crop, and chilies, and all commercial crops, food crops. Most common type of pollen transferring agent is honeybees. Honeybees is an example for insect. So this kind of pollination is entomophily. Next, ornithophily. Pollination by the birds. Ornithophily. This is the smallest bird, hummingbird. Very efficient for the transferring of pollen from one plant to another plant. Pollination by birds. Ornithophily. Next one, pollination by bats is the chirapterophily. Pollination by bats. It is the night moving animals. Some of the flowers open during night time only. In such kind of flowers, pollination is more comfortable by the bats. The technical name of such bats are chirapteros, so chirapterophily. Pollination by the bats is chirapterophily. Banana plant is also a very good example for chirapterophily. Next, pollination by snails. Snail is also act as one of the pollen transferring agents in the small herbaceous plants. Chirapterophily. By the snails, melacophily. Next, pollination by squirrels. Squirrels is the therophily. Pollination by squirrels, therophily. Pollination by the snakes, ophiophily. Snakes belongs to one separate class, that is Ophiopsida, Ophio snakes, pollination by Ophiophily. All these are the types of anemophilous flowers or anemophilous types of pollination. Once again, what are the types of anemophilies? Based on type of animal, it is classified into different categories. Among these different types of zoophilous plants, entomophily is the more dominant. Okay, zoophily classified into different categories. Pollination by insects, say the entomophily is the kind of zoophily. Pollination by the birds, ornitho. Pollination by bats, chiropterophily. Pollination by snails, malacophily. Pollination by squirrels, therophily. Pollination by snakes, Ophiophily. Types of pollen transferring agents or pollination agents, mainly divided in two categories. Living agents means biotic. Is the pollination carried out by the biotic agent that is called zoophily. Zoo animals are the main pollen transferring agents. Abiotic agents, non-living agents. If the non-living agent is the wind is the agent that are called wind pollination or anemophily. Anemophily. Water is an pollen transferring agent, that is the hydrophily. Hydrophily. If the flower is the colorful, more fragrant and rich in nectar, then such kind of flowers are commonly found in zoophilous plants or hydrophilous plants or anemophilous. Colorful flowers, big and showy flower is the characteristic feature of zoophily. Flower non-colored, smaller, there is no emission of any kind of scent or fragrance, no nectar is. These are the characteristic feature of anemophilous, means wind pollinated, hydrophilous, water pollinated flowers. Pollen grain number is more lightweight, small in size and dry are the characteristic features of anemophilous or wind pollinated. Wind pollinated. Stigma is the feathery and sticky is the character of wind pollinated flowers. What are the further types of zoophilies? Based on type of animal, these are classified into various categories. Honeybees or insects are the agents for the cross pollination, that is entomophily. Bats, chiropterophily. Insects, entomo, bats, chiroptero, birds, ornitho, snails, melaco, squirrels, thero, snakes, Ophiophilies. These are types of pollen transferring agents. Some model questions. Try to answer for these questions. Try to answer. Pollination by animals. Pollination by animals. Answer. Yes, zoophily. Here, anemo term may also a confusing word. Animal, anemo. Anemo means wind. Zoo, technical name of animal. What is the main purpose of the pollination? Transfer of pollen from anther to stigma. Within the pollen, two male gametes are there. Observe this animation here. Stigma, style, ovary. ovary style stigma. It is the pollen. Stigmatic secretions can recognize that pollen is the right pollen or wrong pollen. If that pollen is the right, then only the secretions allow to germination of that pollen on stigmatic surface by providing nutrients. During pollen grain germination, pollen tube is formed that gradually elongates and finally reaches to ovary to fertilize the ovule. To fertilize the ovule. Already you learned about the structure of ovule in previous classes. At the ovule structure, inside of ovule, embryo sac is there. Embryo sac consisting of 7-celled 8-nucleate condition. 7-celled 8-nucleate condition. Egg cell with 2 synergids always present towards the micropylar area. 3 antipodals of an embryo sac present towards telogal side. At the middle portion of an embryo sac, 2 polar nuclei are there. It is the central cell. It is about embryo sac developed inside of ovule. In overall structure, carpel is the very bigger. Inside of carpel, fertile portion is the ovary. Inside of ovary, one to many ovules are there. Each ovule consisting of one female gametophyte. Another name of that female gametophyte is an embryo sac. The main idea of embryo sac is production of single female gamete, nothing but egg. This is the egg cell. It is the egg. Tell me once again, what is the place of egg? Or what is the place of female gamete in flowering plants? Egg is found inside of an embryo sac. Place of embryo sac inside of ovule. The place of ovule inside of ovary. Ovary is the part of a carpel. Carpel is the part of gynoecium. Gynoecium is the female reproductive part of a flower. Gynoecium possesses one to many carpels. Ovary is one of the part of carpel. Number of ovules are 1 to many in each ovary. 1 to many ovules in each ovary. In each ovule, single embryo sac is there. That single embryo sac possesses only one egg. These are the different levels of organization in female organs of the plant body. Gynoecium is very bigger when compared to all remaining other structures. Gynoecium possesses one to many carpels. If only one carpel is there, the name of that gynoecium is the monocarpellary. 2 carpels, bicarpellary, 3 carpels, tricarpellary, likewise. Many carpels are there, multicarpellary. Papaya plant, tomato are example for multicarpellary gynoecium. Paddy, wheat, mango are example for monocarpellary ovaries. Inside of carpel, single ovary is there. Inside of ovary, ovules are one to many. Inside of ovule, only one embryo sac is there. Inside of single embryo sac, only one egg is there. Now the functioning of pollen. Tube is sperm carriers. Within this pollen tube, one vegetative cell is there. Single vegetative unfertilized cell, unfertile cell. Remaining 2 are sperms. 2 sperms. These are non-motile. Another name of sperms, male gamete. That male gamete or sperm carries the pollen tube. In embryo sac, it is the synergid area. Synergid. In that one filiform apparator, finger-like projections are found in this filiform in synergid area. The synergid is able to secretion of some kind of chemical substances to guide the entry of pollen tube into an embryo sac. The chemicals are released from this filiform apparatus of synergid, guide the entry of pollen tube. guide the entry of pollen tube into an embryo sac. Okay. When the pollen tube enter into this embryo sac, then both the sperms discharge into synergid cell. So the main functioning of synergid is male gamete receiver. Male gamete receiver. Main functioning of the pollen grain or pollen tube is sperm carrier up to the embryo sac. Sperm carriers or male gamete carrier is the pollen tube. So the ultimate aim of pollination is to carry or to transfer sperms from anther to ovary areas and ovule areas. Okay, it is about complete discussion about pollination. Among these two types of pollinations, autogamy and allogamy, which one is the more beneficial for the plant? Among these two types of pollinations, autogamy and allogamy, the more beneficial kind of pollination is the allogamy cross pollination. Because the cross pollination leads to the genital recombinations or variations in the progeny. Allogamy cross pollination leads to genital recombinations, genital recombinations leads to variations, variations leads to origin of species, that is the beginning for evolution. To proceed evolution, new species formation required. For new species formation, genital recombination. Such genital recombinations are possible by allogamy cross pollination only. Okay. Thank you, Nan. In tomorrow class, I will explain the detailed account of fertilization. In this sexual reproduction, male gamete of development, female gamete of development, pollination topic is completed. Next and last topic of the sexual reproduction is fertilization. Okay, bye now.
Hello everyone, how are you? So nice to see you all. So today we are going to start the tissues only we are continuing, and we are going to start today muscular tissue, right? So in my first class I have given you the introduction of the animal tissues and I have briefly explained about the epithelial tissue. In my second class I have explained you about the corrective tissue, and then in my third class I have explained you about the blood. So yesterday's class was all about the blood. Yes, so we have discussed blood has plasma and formed elements. Plasma has maximum water, 90 to 92% water, and rest is the dissolved solids, the hormones, gases, nutrients, anticoagulant, salt, electrolytes, right? All these things are dissolved in the plasma, and the cells are known as formed elements. So we have discussed three types of formed elements: RBC, WBCs and platelets, right? And then further we have discussed the type of WBCs also, granulocytes and agranulocytes. All of them together are 5 types, right? 3 are granulocytes and 2 are agranulocytes, right? So you can go through that from the NCERT and you can understand, right? So now, all right. So now let us start with today's class, and that is muscular tissue, beta. Muscular tissue. All right. Muscular tissue. I have already told you muscular tissue origin. Yes, now again tell me. Tell me, do you remember the origin of the muscular tissue? What is the origin of muscular tissue? What is the origin of muscular tissue? Yes. What is the origin of muscular tissue? Quickly tell me. Mesoderm. Mesoderm. Mesoderm is the origin of muscular tissue. Yes, it is mesodermal in origin. Mesoderm origin. And what is the function? It makes beta muscles. So muscular tissue forms your muscles. Your muscles. Muscles are made up of muscular tissue, beta. Muscles are made up of muscular tissue. So we will understand about the muscular tissue and muscles, right? So you have 3 types of muscles, you know that. But first of all, we will look into a basic structure of muscle and properties of muscle, right? And do you know that whatever is your body weight, 40 to 50% of the body weight is contributed by muscles, beta. So if you know your body weight, you can calculate What is the weight of your muscles? 40 to 50% of the body weight is given by the muscles. So muscles, they contribute 40 to 50% of the body weight, contribute 40 to 50% of body weight, right? Now muscles are, I will make a diagram, and with the help of a diagram I will tell you that the muscle is made up of muscle bundles, beta. So let us suppose this is a muscle. Let us suppose this is a muscle, and in this muscle there are so many muscle bundles, like this is one muscle bundle, this is another muscle bundle, right? This is another muscle bundle. So many muscle bundles are there. So many muscle bundles are there, like this. Another muscle bundle, this is another muscle bundle. So these are muscle bundles, beta. And in every muscle bundle there is a muscle fiber. So many muscle fibers are making this bundle. Alright. This is muscle fiber. Muscle fiber. So the pink colored one, I am giving you a cross section of the muscle, beta. I am giving you a cross section of the muscle. The pink ones are the muscle fiber. You can consider muscle fiber as a muscle cell. So these are the muscle fibers. What is the pink colored one? Everyone look here. The pink colored one is a muscle fiber, beta. This is muscle fiber. This is muscle fiber. You can consider muscle fiber as a muscle cell. Muscle cell. Alright? Alright? So muscle cell is considered as a muscle fiber, or muscle fiber is considered as a muscle cell. So basically muscle fiber is a muscle cell. Right? Now this muscle fiber is present like a bundle. So many muscle fibers are there and they are present in a bundle. So this is a bundle of muscle fiber. The next thing you are seeing here is, this is a muscle bundle, this is a muscle bundle. So these are what? These are muscle bundle. There is another name for muscle bundle, that is fascicle, beta. This is also known as fascicle. Fascicle. So muscle bundle or fascicle. This is muscle bundle or fascicle. And the group of muscle bundles is making the muscle. So can we write that muscle is made up of muscle bundles? Muscle is made up of muscle bundles. And can we write muscle bundle is made up of muscle fibers? Yes. Now, muscle fiber is made up of what? This muscle fiber is made up of myofibrils, beta. Myofibrils, or you can say myofilaments. These myofilaments or myofibrils are made up of proteins. So these myofibrils or myofilaments, they are made up of proteins. They are made up of proteins, and there are two main proteins. One is beta actin and another is myosin. One is actin and another is myosin. Two proteins are there which are making the myofilaments or myofibrils. So here you have to remember, muscle is made up of muscle bundles, and every muscle bundle has many muscle fibers. That's it. Right? This much you can remember. So muscle fiber is a muscle cell. Right? Now all these muscle bundles are held together by a connective tissue sheath, by a common collagenous connective tissue sheath. So that, see, connective tissue is coming. Connective tissue is most abundant tissue. Connective tissue is coming into the muscular tissue also. I have told you connective tissue is present below epithelial tissue also. So that is how you can understand that connective tissue is the most abundant tissue. Alright? Right? So here let me show you the connective tissue. This is the connective tissue here, present here. This is the connective tissue. This tissue is the connective tissue. In between the muscle bundles, there is connective tissue, beta. This is connective tissue only. This is connective tissue here. This is the common collagenous connective tissue, which is known as fascia. Which is known as what? Fascia. So it holds all the muscle bundles together. So if somebody will ask you what is this yellow colored one, this is beta fascia. This is fascia. Fascia. And what is this fascia? Fascia holds all the fascicles together. That is why you can relate the names to each other. Fascicles are held together by fascia. So let us write what is fascia here. Fascia. Fascia is the common collagenous connective tissue sheath which holds muscle bundles together, which holds muscle bundles together or fascicles together. So that is fascia. So here you have understood what is present in a muscle. In a muscle there are muscle bundles. In a muscle bundle there are muscle fibers. That's it. And every muscle fiber is considered as a muscle cell. So just like in a cell there are cell organelles, just like in a cell there is nucleus, just like in the cell there is cytoplasm, just like in a cell there is the cell membrane or plasma membrane. Everything is present in the muscle cell also. The muscle cell will also have a plasma membrane, the muscle cell will also have a cytoplasm, and that is known as what? So if somebody will ask you about the muscle fiber, you can tell this muscle fiber is a muscle cell and this cell has cytoplasm. So cytoplasm of muscle fiber, plasma membrane of muscle fiber, plasma membrane of muscle fiber, endoplasmic reticulum, endoplasmic reticulum of muscle fiber is known as what? Important. These terms are important, beta. These terms are important. So cytoplasm of muscle fiber is known as sarcoplasm. Sarcoplasm. Plasma membrane of muscle fiber is known as sarcolemma. Sarcolemma. Endoplasmic reticulum of muscle fiber is known as sarcoplasmic reticulum. Sarcoplasmic reticulum. And there is a very special thing about the sarcoplasmic reticulum, that it stores calcium. It is the storehouse of calcium, beta. It is the storehouse of calcium. It is the storehouse of calcium. It is the storehouse of calcium. It stores calcium. Sarcoplasmic reticulum. Do you know calcium is required for the muscle contraction? Do you know calcium is required for the muscle contraction? So that is why so much of calcium is there in the sarcoplasmic reticulum. When calcium will come out, then it will initiate the muscle contraction, and that we will understand in the another chapter of human physiology, that is locomotion and movement. We talk about the details of muscle in the locomotion and movement chapter, beta. So I will now move to the next page and I will tell you the properties and types of muscle. But before that, please confirm me that you have understood this or not. Have you understood that muscle is made up of muscle bundle and muscle bundle is made up of muscle fiber? So now let us move ahead and understand the properties and the types of muscle. So I am moving ahead. First of all, there are 4 important properties of muscle. 4 properties. Properties of muscle. Properties of muscle. Right? Properties of muscle. The one property, the very, very important property is beta excitability. 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 Do you know the meaning of excitability? Excitability means, okay, let me tell you with the help of the example. So excitability means just like when teacher comes into the class and you get excited to study. But before that you were normal, hai na? Yes or no? That's what you do. Similarly, let us suppose I will tell you something good, so you will become excited. Let us suppose I will tell that if you will give the answer, I will give you a chocolate, so you will get excited for the chocolate, or maybe for any other gift, or like anything. Like excitement, excitability, similar kind of thing. Excitement and excitability, similar kind of thing. When the muscle is not doing any work, then it is at rest. But when the muscle will get any stimulus, when the muscle will get any information that now you have to do work, so at that time the muscle will get excited to do work, right? That is excitability. You will understand excitability in more detail in the nervous tissue when we talk about the generation of nerve impulse. This is a topic, right? So you understood excitability, all of you are excited to know more properties also. So let me tell you more properties now. After excitability, muscles have extensibility. Let me give you the best example of extensibility. Let us suppose you are sitting on a sofa and you are watching a TV, right? You are watching match. Nowadays, the IPL is there, na? So match. You are watching match, right? You are sitting on sofa, one side of a sofa, and sofa is, you know, the length of the sofa is very much. So now on the other side, there is on the other hand, there is a remote. Now you are too very lazy. You are too lazy to get up and go to the another corner and take the, remote if you want to see now something else. So what you will do? You will just extend like this. Extend, hai na? Extend like this. Hai na? You try to extend your body. Why? Because your body has muscles and your muscles have extensibility. So you will extend, which can little bit elongate. That is extensibility, extend, right? But flexibility is different. Flexibility comes because of the elasticity. Because we have, our muscles have another property, that is elasticity, Ritvik. Yes, Ritvik, it is elasticity. Flexibility and elasticity is same. Extensibility is different. Means you are stretching it. Yes, correct. So extending it. So extensibility. Then there is elasticity. 3 E's. Excitability, extensibility, elasticity. Elasticity. Movability. Elasticity. Right? It is not tough. It is not hard. It is elastic. It is movable. It is flexible. Right? So elasticity. Then there is contractibility. Contractibility. They have the ability of contraction. Muscles can contract, muscles can relax. Excitability is to respond to the nerve impulse. But because you don't know what is a nerve impulse, that is why I am not telling you this, right? The nerve impulse is a different thing. I will teach you nerve impulse in the neural control and coordination chapter. Here I am explaining these terms with a simple, simple examples. So that is why. So that you will remember these. So now you will remember excitability. Now you will remember extensibility, elasticity, contractibility, right? Contract, relax, contract, relax. Muscles will contract, relax. I will also teach you in the locomotion and movement chapter how the muscles are contracting. What is the mechanism of contraction and relaxation? So now, properties are done. Let us talk about the types of the muscles, beta. Types of muscles. Types of muscles. So there are 3 types, everyone. There are 3 types. 3 type of muscles are there. 3 type of muscles are there. Skeletal muscles, skeletal muscles, also known as striped muscles, also known as striated muscles, also known as voluntary muscles, All these are the names of skeletal muscle, beta. Skeletal, striped, striated, voluntary, because these are the only muscles which we can control. Yes or no? So skeletal muscles are voluntary muscles. Voluntary muscles means we can control. Next is smooth muscles, beta. Smooth muscles, we can call them unstriated muscles, right? Then the third one is cardiac muscles, beta. Cardiac muscles are only and only present in your heart. They are only and only present in your heart. They are not present anywhere else. They are very special muscles. They are the muscles of the heart, right? Heart, right? So you can send me heart in the chat section if you have understood this, right? Now the structure. Let us see the differences in the structure of muscle fibers. These are the muscle fibers of the skeletal muscle, beta. These are the muscle fibers of the skeletal muscle. So you can see that they are cylindrical. Yes or no? Yes, everyone. Yes, everyone. Thank you for so many hearts. From my side also, heart is there, right? Heart is there. So now let us first understand. Everyone now focus here and understand. So what is the shape of skeletal muscle? Cylindrical. This is muscle fiber. I am making muscle fiber, beta, because you know muscle fiber or muscle cell is the unit which is forming the muscle, right? So this is the muscle fiber. So if somebody will ask you about the muscle fiber of skeletal, smooth and cardiac muscle, so muscle fibers are cylindrical. Muscle fibers are cylindrical. First of all, you can see the cylindrical shape, right? Then in the muscle fibers, you will see some striations, beta, striations, stripes. Like you will see the light band, dark band, light band, dark band, right? This is light band, then dark band, then again light band, then again dark band, then again light band, then again dark band, like this. You will see some kind of stripes or striations, So that is why prominent striations you will see. Prominent means they are very, very much visible, Let us suppose you have bought a new t-shirt, and on this new t-shirt you have stripes, beta, stripes, black and white, right? So black is the dark, you can say, and white is the light one, you can say. So dark, light, these are the bands, dark and light bands. So these dark and light bands are very, very prominent when you have bought a new t-shirt. But let us suppose now you are wearing that t-shirt daily, है ना? Washing it, wearing it again, because it's your favorite maybe. So you're washing it, wearing it again, washing it, wearing it again. So after so many washes, what will happen to the stripes? The color will remain same or it will fade away? Yes or no? The color will remain same or it will fade away? It will become faint, faint, light. Yes or no? Yes or no? Are you understanding what I am explaining? So it will change. Yes, it will change. So those type of striations are present in cardiac muscle. So if somebody will ask you which type of striations are present in the skeletal muscle, you will say prominent striations, prominent striations. But faint striations are present in the cardiac muscle. Cardiac muscle also have striations, beta. Cardiac muscle also have striations. Let me show you here. These muscles are also cylindrical, but they are branched also. Can you see here? They are branched also. So you can see that I am making a branching. Yes or no? I'm making a branching kind of a thing. So here you can see the branched muscle fiber. They are branched, beta. They are branched. But here there is no branching. No branching. So unbranched. These are unbranched. These are unbranched. Right? So here can I write that they are also cylindrical but branched. These are beta cylindrical. Cardiac muscle fibers are cylindrical. Just like they are cylindrical, just like the skeletal muscle. They have also striations, but they have faint striations. They have faint striations. They don't have prominent striations. Right? I will show you the faint striations here. So these faint striations I will make like this. Very light striations. Very light striations are there. Very light striations. There it is dark, dark striations, but there it is light striations, right? Dark strips, light strips, like that you can remember, like that you can understand. Okay, now these are unbranched, but can we write that these are branched? These are branched. So let me make the smooth muscle fiber also. The smooth muscle fiber is having a different shape, that is this shape, beta. Spindle shape, this shape, spindle shape, like this. The ends are pointed. Tapering ends, and this is the nucleus. They are uninucleated, right? So they are, can we write that they are not cylindrical, they are spindle shaped. They are spindle shaped, right? They don't have striations, no striations, beta, no striations. And they are also not branched, so they are unbranched. Are you understanding these differences, everyone? Are you understanding this much differences? Yes, please tell me. Are you understanding this much differences? Are you understanding this much? The shape of the muscle fiber, right? The shape of the muscle fiber, the striations, the branching. Now let us understand the nucleus. If you see here the skeletal muscle, beta, if you see here the skeletal muscle, there are so many nucleus. There are so many nucleus in one muscle fiber. This is one muscle fiber. This is another muscle fiber. This is another muscle fiber. And in every muscle fiber, many nucleus are there. Many nucleus. Here I am making so many nucleus. Many nucleus. So the skeletal muscle fiber is multinucleated or uninucleated? Multinucleated or uninucleated? It is multinucleated. So the skeletal muscle is multinucleated, and multinucleate condition is known as syncytium. Multinucleate condition. What is the another name for multinucleate condition? Syncytium. Whereas these are uninucleate, beta. These are uninucleated. They are uninucleated. Let us see the cardiac muscle also. They are also uninucleated. So there is a special thing here. You will see a kind of a dark band, and that dark band can be called as intercalated disc. Like this is one disc. Let us suppose this is another disc, right? Let us suppose this is another disc. So is it visible? The pink colored disc is visible to everybody or not? Yes or no? Tell me. Is it visible to everybody? This is the intercalated disc, beta. Is it visible to everyone? The intercalated disc. So what is the name of this pink colored disc? It is, beta, intercalated disc. Intercalated disc. It is intercalated disc. And this is the junction between adjacent cells. It is the junction between adjacent cells. Adjacent cells. I have told you na, junctions are present in epithelial tissue, but junctions are also present in cardiac muscle, muscular tissue. So where you are seeing the junction, apart from epithelial tissue, you are also seeing the junction in the cardiac muscle. Okay, now I was explaining about the nucleus of the cardiac muscle. Very, very important point, beta. Very important point. This intercalated disc is the junction between adjacent cells. So that is why we will consider this as one cell and this as another cell. Because this is the separating. This is separating the different cells. This intercalated disc is separating the different cells. So here they will be uninucleated. This is one nucleus I am making. So one nucleus in one cell, right? Then this is another cell, so another nucleus. Then this is another cell, so another nucleus. This is another cell, so another nucleus. This is another cell, so another nucleus. This is another cell, another nucleus. This is also one nucleus, this is also one nucleus. So here we can say these are 3 muscle fibers. But here we cannot say there are 3 muscle fibers. Here 1, 2, 3, 4, 5, 6, 7, 8 muscle fibers I have made, because 8 nucleus. And these 8 muscle fibers, they have a junction between the cells, and that junction is known as beta intercalated disc. So if somebody will ask you intercalated disc is present in which muscles? Intercalated disc is present in cardiac muscles. If somebody will ask you intercalated disc is absent in which muscles? In both the skeletal and smooth muscles, right? Now let us talk about their location, beta. Location. What is the location of skeletal muscles? That is their name suggests. Location. Skeletal muscles are present around the skeletal system. So skeletal system is made up of bones. Those are making your endoskeleton, right? Those are making your endoskeleton. So location of skeletal muscles will be around skeleton. They are present around skeleton. They are present around skeleton. Skeletal muscles are attached to the skeleton. These are skeletal muscles. We have endoskeleton bones, right? 206 bones. Yes, Madhavi. So we will, when you'll come to the campus, I will teach you each and every bone here, right? In the locomotion and movement chapter. So the bones are the skeleton, and the muscles which are attached to these bones, the muscles which are attached to the skeleton, they are known as skeletal muscle. Smooth muscles are present in our internal organs. In every organ, smooth muscles are present. So they are present in internal or visceral. Internal organs are also known as visceral organs, beta. So they are present in visceral organs, right? Whereas cardiac muscles, I have already told you, they are exclusively present in heart. Present in heart, right? They are present in heart. Now the nature of the muscle. Nature of the muscle, whether we can control them or not. Yes, we can control skeletal muscle. They are voluntary in nature. But the other 2 types of muscles we cannot control. Yes, we cannot control, na? We cannot control our internal organs. We cannot control our heart as well, right? So it is involuntary, beta. Involuntary. 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 Right. Then because we are, the skeletal muscles are in our control. So we are using our skeletal muscles so much. So that is why we get tired. These muscles can get tired, beta. So what is the meaning of tired here? What is the another name of tired here? Fatigue. So they can fatigue. They can fatigue. These cells can fatigue. These muscles can fatigue. They can get tired. So they can easily fatigue. Can easily fatigue. Easily fatigue. But if you see the smooth and cardiac muscles, they won't fatigue. They won't fatigue. We can write here, they rarely fatigue. They rarely fatigue. Fatigue means tired. They rarely fatigue and they never get fatigued, beta. If they will get tired, na, your heart will stop beating. And you know then what will happen. So they never get fatigue. They never get fatigue. So these are the differences between the skeletal, smooth and cardiac muscles. You should know the differences in the muscle fibers. You should know the differences in the location, nature and everything else. Right? The question, yes, these are all the basics, beta Pinky. So the questions will not be in the differences. They can also ask you the similarity. For example, if they ask you what is the similarity between skeletal and smooth, tell me the similarity between skeletal and smooth. Is there any similarity between skeletal and smooth, beta? Any similarity? No similarity. Yes, can you find any similarity? I can tell you one similarity. Any similarity? Similarity between skeletal and smooth. Unbranched. Very good, Madhavi. Very good. Unbranched. This is also unbranched. This is also unbranched. Very good. Very good. Unbranched. Unbranched. That is the similarity. Differences are so many, but sometimes they will ask you the similarity. So this is the similarity. Now, can you tell me the similarities between skeletal and cardiac? Skeletal and cardiac. What is the similarity? Cylindrical muscle fiber. Cylindrical muscle fiber. Cylindrical muscle fiber. Striations. Cylindrical muscle fiber. Yes, striations are also there. In both of these, striations are there. But the difference is, in one there are prominent striations, in one there are faint striations. Okay, now let's come on. Let's see the similarity between smooth and cardiac. Everyone, uninucleated, very, very important. Uninucleated. Here also it is uninucleated. I have not written, but I have made one nucleus in every muscle fiber. Uninucleated. Uninucleated. And now you should remember the differences also as well as the similarities also. Yes, beta, this is voluntary. These two are involuntary. So involuntary is also a similarity between the smooth and cardiac. So there can be more than one similarities also. Yes, they don't fatigue. That is also a similarity. So you can see three similarities: uninucleated, uninucleated. You can see involuntary, involuntary. You can see they also don't get fatigue. They also don't get fatigue. Yes or no? Alright, so let us conclude today's class. This was all about the basics of the muscle and muscular tissue. Right? More details will be taught related to muscle in the locomotion and movement chapter of human physiology. Right? So now we will end here this session today, and in tomorrow's class I am going to explain you about the last tissue. Which is the last tissue which is left? Yes, quickly tell me. Nervous tissue. So tomorrow we are going to understand about nervous tissue. Alright. So bye bye. Take care. God bless you all, and like the session. Don't forget to like the session. Okay. If you like my lecture, if you like me, just like the session. Subscribe to the channel because Madhu ma'am is telling you to subscribe. Okay. Chalo. Bye bye beta. See you tomorrow.